Fat is definitely a tissue that we've all spent some time thinking about, whether it's how it looks in the mirror, if we want to lose some of it, or what it means for our health. But unfortunately, fat often gets painted as the evil villain of our health and fitness stories. And don't get me wrong, fat can result in negative health consequences in many situations, but it is also absolutely critical to human survival and does way more than most people even realize. So today, we're going deeper than we ever have before into the incredible world of fat, so that we can lay the foundation to help us figure out when it can be good and when it can be bad, so that you can make better health decisions when it comes to your own fat. We'll do this by exploring its many functions, from storing energy to producing heat and hormones, and talking about the fascinating differences in fat with babies versus adults, and why males and females tend to have different body fat percentages, as well as how our human ancestors would have never made it without fat. It's clearly going to be a fun-filled fatty one. So let's get into this anatomical awesomeness. Now, I think we can all agree that sometimes there are some negative stereotypes with fat, but from an evolutionary perspective, animals, humans included, would have never survived without this important tissue. So what exactly is fat and why do you need it? Well, scientifically speaking, fat is called adipose tissue, and I'll use those terms interchangeably throughout the rest of the video. But fat, or adipose tissue, is actually classified as a type of connective tissue, which you can see here on this cadaver dissection, just deep or underneath this thin layer that I'm probing right here, which is the skin. Now, to the naked eye, it looks like this soft, oily, padded layer, but if we were to zoom in to the fatty tissue and look at it from the microscopic level, you'd see adipose tissue is made up of cells called adipocytes. And these are like tiny warehouses that store fat as triglycerides, which are a glycerol molecule bonded to 3 fatty acids, forming a big droplet that shoves the nucleus aside like it owns the place. But why was adipose tissue essential to our survival? Well, the answer to this comes from its many different functions. Adipose tissue is quite the multitasker. It stores energy, provides insulation, and can actually even produce heat. It also cushions and protects organs, and it even acts as an endocrine organ because it secretes various hormones. Now, think about how important the energy storage part is. Early human ancestors didn't have refrigerators or food available around every corner. So in a way, we had this primitive wiring in our wonderful brains to influence us to eat as much as we could whenever we could, because we didn't know when our next meal was going to be. And admittedly, even in 2025, sometimes we forget about the wonderful development of our prefrontal cortex, and we revert back to our primitive ancestral wiring, forget we're going to have another meal available to us soon, and just gorge ourselves on food. It happens to me in the movie theater. My primitive feast or famine wiring kicks in and I just can't stop eating that popcorn. But again, this was an effective strategy for survival. We could pack this organ, the wonderful human stomach that you can see here, with quite a bit of food. And this stomach that we have here, I can turn inside out to show you these folds called gastric rugae that really allow for the stomach to stretch and get packed full of liters of food. And if you want to know exactly how many liters, check out our How Much Food Can the Stomach Hold video at the end. But after we packed the stomach full of food and the food was digested and absorbed, we could store the excess as fat, which was an absolute lifeline for hunter-gatherers, fueling long hunts and surviving famines for weeks at a time. Like, for example, even a fairly lean person can store anywhere from 60 to 100,000 calories, depending on exact body fat percentage. And there's even evidence to suggest that human ancestors had higher body fat percentages than other primates, which is thought to be one of the contributors to the brain size increases during that evolutionary time period. And humans by far have the highest brain to body ratio, making us the smartest creatures on the planet. At least we're supposed to be. You don't have to spend very much time online observing human activity before you start to question that, but I digress. So have you ever wondered why females typically have more body fat than males? Like, a fairly lean, healthy male could have anywhere from 10 to 15% body fat, but a comparably healthy female could have 20 to 25% body fat. Well, there are multiple factors that contribute to this difference, such as the differing effects of testosterone and estrogen. For example, testosterone tends to reduce fat accumulation while stimulating muscle protein synthesis, whereas estrogen tends to increase fat deposition, especially in the subcutaneous areas of the hips, thighs, and breasts. But this can all really be attributed to reproduction. Pregnancy requires about 300 to 400 extra calories per day, depending on the trimester. Now, that may not sound like a lot in 2025, but again, remember, our human ancestors did not have food available like we do. Now, this increased calorie requirement would even be higher in the case of twins, plus breastfeeding requires about an additional 500 calories per day. So there was a huge evolutionary drive to allocate ingested resources for different purposes in males and females. Males needed less body fat as their primary evolutionary role was hunting and protection, so use those ingested calories for muscle mass over energy reserves. Whereas with females, ensuring the survival of both mother and offspring during food scarcity was essential. And so a much bigger priority was to use those ingested calories for energy reserves, or in other words, build up the fat storage. And you've probably heard that low body fat percentages in females can disrupt menstrual cycles, and a female will stop having a period. And it's kind of the body's way of saying, I don't have enough fat storage for pregnancy, so it's probably best not to allow the pregnancy to occur. Obviously, evolution did not predict the future of food availability because nowadays most females rarely experience times of famine where they would have to rely on energy stores and adipose in order to support the pregnancy. It's really easy for us to get those 300 to 400 extra calories today. So let's shift to some other essential and fascinating functions of fat. And to do this, I want to discuss the different categories of fat. Fat can be categorized by color as well as by location. As far as color, fat is either categorized as white fat or brown fat, which you could also call white adipose tissue or brown adipose tissue. Now, in adults, the majority of fat is white fat, which you can see here. Now, obviously, on this cadaver dissection, the fat looks quite yellow, and in a living person, the white fat does have a pale to yellowish color, but the preservation process changes that a little bit. But brown fat, as the name implies, has a darker color, and it obtains this darker color from a very rich blood supply, along with being packed with specialized pigmented mitochondria. And remember these mitochondria because we'll talk about how fascinating they are in just a second. Brown fat is found in much higher amounts in the fetus and infant, and so found in much smaller amounts in the adult. Adults maintain some of it around the clavicles, neck, and a few other places, but again, the majority of fat in adults is white fat. Now, both white and brown fat are involved in thermoregulation, which is maintaining body temperature, but they do it in very different ways. White fat is kind of like the insulation in the walls of your house, and so you can kind of think of white fat as the insulation just beneath your skin, which prevents heat loss from the body. So the white fat does not produce heat, just like the insulation in your house does not produce heat. It just helps prevent the heat from leaving. Whereas brown fat can literally produce heat. Remember those little specialized pigmented mitochondria that the brown fat was packed with? The typical mitochondria that you've learned about in a previous biology class that are found in all the other tissues throughout the body take oxygen with either carbohydrates or fats and produce the energy currency of our cells called adenosine triphosphate or ATP. However, the mitochondria in brown fat have a unique decoupling protein, and because of this, the mitochondria in brown fat do not generate ATP. Instead, they utilize oxygen with either carbohydrates or fats, so they use the same fuel, but instead of producing ATP, they literally produce heat, which is referred to as thermogenesis. And remember how we said that brown fat had a very rich blood supply? The heat generated by these specialized mitochondria in the brown fat can now be carried away by the blood to other body tissues in order to warm them up. But you might be wondering, why do infants have a higher concentration of brown fat than adults? Well, have you ever seen a newborn shiver like an adult does when they're cold? Shivering is another form of thermogenesis and can actually produce a substantial amount of heat. But newborns don't have the ability to shiver in the same way that adults do. They lack sufficient muscle mass and still haven't developed the neural pathways to get a full-fledged shiver going. So instead, they rely on this non-shivering form of thermogenesis, and this is why brown fat was so essential to the survival of a newborn. Earlier I mentioned that fat can also be categorized by location, and this is where we get into subcutaneous fat versus visceral fat. Subcutaneous literally translates to below the skin, and so subcutaneous fat is found below the epidermis and the dermis that you can see here, but it also covers up muscles, and it can be millimeters thick all the way up to several inches thick. And so people who are concerned about Muscular definition will often try to make this subcutaneous fat as thin as possible. Visceral means pertaining to internal organs, and so this is the fat that surrounds and protects your organs. Both visceral and subcutaneous fat are primarily made up of white fat, so they will be utilized for energy storage and will help to insulate the body, and both visceral and subcutaneous fat also produce hormones. This includes hormones like leptin to regulate hunger, adiponectin, which enhances insulin sensitivity and has anti-inflammatory effects. It even produces estrogen by converting androgens, which are the primary male sex hormones, into estrogens via the aromatase enzyme. It also secretes various cytokines, which are signaling molecules that are involved in the inflammatory responses. So up to this point, we've learned that fat has some pretty incredible functions that were beneficial and essential for the evolution and development of humans. And even today, fat is essential for the proper functioning of the human body. But just like many other processes in human physiology, fat follows the Goldilocks principle. You don't want too little of it, you don't want too much of it, you want it in the right amounts. So in our next video on fat, we're going to discuss all the many health problems that excess fat can have on the human body, and more importantly, why excess fat leads to those health problems. And even get a little bit into when I was accused of fat shaming. So depending on when you're watching this, that video will be released in a week or two, or maybe it's already been released, which if it has, I'll link it here.